Hi everyone, today I'm going to introduce you to a new API, the Grid Operators API, designed specifically for DSOs and TSOs to actively manage the grid. Up until now, we already had the Asset API that was designed for communities, vendors, aggregators, and data scientists to manage multiple type of energy assets, loads, PV, and storage, aggregate them to optimize a community or houses. The grid operators will act on behalf of the market and will actively manage different markets. It can manage different markets on different level of the grid, such as you can see here. It would manage the community A, the community B, the zip code, for instance, and also the grid. With this API, the agent can request information on these markets, such as the volume traded, the price, and also some other KPIs. It can build a strategy and then send the new grid fee for each of these markets. So I'm going to show you in the UI. So I'm running here a collaboration. We have here the grids, the market maker, which will sell and buys an infinite amount of energy, the community of 25 households. In the registry, I use the DSO role and I have registered to the grid market and to the community market, as you can see here. We have a template script that you can run in Python. And basically here I'm registering to the markets that I have already applied, so the grid and the community. We have two templates of grid tariff. The first one is the time of use, which sets a new grid fee for each defined time of the day. And we have the as-is model, which is a grid tariff that is much more reactive because it reacts to the latest past peaks, import and export of a specific market. So here for the example, I'm going to use the time of use. So let's start my script. So I'm connecting to the two markets, the grid and the community. Once I'm connected, I'm launching the simulation. Let's see. Okay, perfect. So now it's running. The script is triggered every market slot with the on-market cycle. And basically it receives information on the past market statistic. So for instance, the total energy traded on each market, so the community and the grid, the price, average, maximum, minimum prices, the self-sufficiency, the energy imported and exported for each of the markets, the last fee, the current one, and also I can change the grid fee for both of the market at the same time. So for instance, here I'm changing the grid fee from 0.5 to 0.52 cents per kilowatt hour. And for the grid, I'm changing the fee from 2 to 2.08 cents per kilowatt hour. And so this function is triggered every market slot. As you can see, it allows you to build smart strategy. Basically here I'm only using a time of use that doesn't react to the condition of the market, but it is possible to build a model that would predict the total demand of the community and the total generation, and based on that react with a much smarter grid fee in order to incentivize the trading agent to reduce the peaks, or for instance for performing some demand side management services. The grid fee is also seeable inside the dashboard of the UI. So here I'm looking at the grid level, and we have the pricing graph, and we have a new line called the grid fee. And as you can see here, my time of use is very dynamic. I'm almost changing the grid fee every 15 minutes. And during the day, I'm increasing the grid fee to reduce the export back to the grids, basically. And I can also look at the community level. Here I'm changing the grid fee a little bit less. So the grid fee can be used to influence the cost of trading. By increasing or decreasing this grid fee, we can incentivize traders to sell or buy energy and to use their flexibility to optimize for specific metrics, such as to reduce peaks of the community or certain area.